Uh-oh. Okay.
Yeah. So, as we start, are there people here online that are new members? Is this their first time, or have people been here before? I take it everybody's been here before.
Judy.
Hi, Judy. You're kind of smeary looking. And muted.
Looks like something's blocking her camera.
Oh, wait, and on Friday we have the outing to. Shut up.
I got those on my list.
Hmm?
I was going to announce them. Going to announce we have Friday. and Saturday.
Yeah.
They're field trips. I think I'd announce it.
I've been out there once. It's kind of neat.
All right. Right. Good evening. This is the May meeting of the Virginia Natural Plant Society, New River chapter. As soon as I paused, you should have seen the looks of the people in the room, like great disappointment, I think, or disbelief. I'm not sure which. We usually start our meetings with an acknowledgement that Beth Umberger wrote for us. This land where we live was historically Tulo-Monacan. However, our ancestors or ourselves arrived in the New River Valley. We are learning a new way of managing the land for biodiversity, which connects all of us to who lived on this land and will live on this land. This gift of native habitats that were managed so well for tens of thousands of years by the Tulo-Monacan people and their ancestors now needs all of us working together to preserve it for future generations. All right. So this evening, we're pleased to have Will Evans. He is the Ecological Restoration Coordinator of the Nature Conservancy in West Virginia. And Will speak about red spruce restoration in the Central Appalachians. The Nature Conservancy has spruce management areas in both Southwest Virginia and in West Virginia. Thank you for being with us.
Yeah, thank you all for having me. I'll go ahead and get queued up here.
Will you make it louder? I can't hear.
And let's see. All right, are you all able to see? Oh, I'm sharing the wrong screen. Let me switch screens. There we are. All right, do you all see a presentation slide?
Yes, we do.
Great. All right. Well, thank you all for having me. My name is Will. I work with the Nature Conservancy in West Virginia. And although I'm in West Virginia, much of the landscape that I work in is similar to that you all are in down in Southwestern Virginia. So I'll be speaking to our red spruce work in Central Appalachia, specifically focusing on the nexus of the climate adaptation and restoration work we do. I'll leave time for questions, but if you all have questions throughout the presentation, feel free to use the raise hand feature, and I'll try and get you at the end of a slide or during a natural break. All right, so we'll dive right in. So kind of an overview of what I'm going to be talking about tonight. I'm going to start with a little bit of spruce ecology, just some basics to kind of lay the foundation for the rest of the talk. Then I'll dive into land use histories, particularly West Virginia land use history, but as I stated before, a lot of land use history is similar across the state lines. Then I'll touch on the why here and why now, why we're doing this work and why it's important in Central Appalachia. Then the restoration methods that we've started using, including assisted migration, spruce release, which is really the main body of my work, and then the riparian restoration work that we do in partnership with the National Forest. And then we'll have some time for questions at the end. All right, so to get started on some spruce ecology. Spruce are a shade-tolerant tree species. And because of that, they're also kind of a late successional tree species. They'll germinate within the understory and can stay living within the understory for up to 100 years before they kind of peter out and lose viability. They're dependent upon small canopy gap disturbances. So if we think of like an old growth forest where trees are naturally aging out of the system periodically over time, or there's wind throw events or ice storm events, those smaller canopy disturbances are what spruce thrive on and what ultimately gets them from seedlings into the understory, then to the midstory, and then to the canopy. They're a particularly resilient species. They will tolerate just about anything. We see them growing with wet feet in creeks. We see them growing on rocky ridgetops where there's little soil. But they're not a very competitive species in the short term. So we don't really see them growing on southern slopes a whole lot. In areas that have large disturbance, like a clear cut, spruce are not going to do terribly well. They're slow growing, tolerant, and resilient, but not competitive in the short term. They're a particularly old, long-lived tree species, up to 400 years old, but they have a very short growing season. At least where I'm at, in West Virginia, everything is leafed out. We're pretty much firmly into spring, and I imagine you all are thereabouts too. Spruce aren't going to start growing for us until probably late May or early June. And then they're going to stop putting on new growth in August, early September, compared to the rest of the hardwood trees in our systems are already growing, have put on leaves, and won't really be leaf off until sometime in mid-October. They're non-fire adapted. They do not respond well to fire. There's estimates that the fire return interval for a spruce-dominated ecosystem is once every 1,000 years, which is to say they don't like fire. They don't burn, or they do burn, but they're not fire dependent. Spruce sequester a ton of carbon. There's some new work that's come out of a master's student at WVU who also works with NRCS out of Morgantown, showing that spruce forests sequester more carbon than any other forest type in Central Appalachia. And they sequester that carbon predominantly in soils. So when we're thinking about climate mitigation, we're thinking about carbon storage and sequestration, spruce is a great tool for doing that in Central Appalachia. And lastly, spruce is great climate refugia. We'll get into this a little bit more. But as we think of things getting warmer and drier, spruce are particularly cool in wet forests. So they kind of sit as the antithesis of what we're expecting to see as climate change further becomes a reality in this part of the world. So the range of spruce, they're a pretty northern species, generally sticking up in New England and Canada, but go as far down as the Smokies in North Carolina and Tennessee. You'll see there's small pockets dotted throughout Pennsylvania, West Virginia, Virginia, and the Carolinas. And these are really at the highest elevations. So they're fairly scattered throughout the Central Appalachians. And so put a pin in that when we're thinking about habitat connectivity and genetic diversity, which I'll get to later. Put a pin in that idea of scattered pockets of spruce. But spruce-influenced forests would have dominated the highlands throughout much of Pennsylvania, Maryland, West Virginia, Virginia, and North Carolina in pre-contact or pre-Columbian times. All right, so we've covered a little bit of spruce ecology. We'll get into land use history. The first thing I'm going to point out is this background photo. So these are loggers during the industrial logging boom, and they're standing next to mature, virgin, old-growth spruce. You can see that these spruce are enormous. This would have dominated much of the highlands throughout central Appalachia, but spruce this size are a rarity today. So when we talk about land use history in Appalachia, we're generally talking about the first big disturbances. Obviously, this land had indigenous people on it who stewarded it, but the first massive disturbances that really changed the entire ecosystem started around 1880. So from roughly 1880 to 1920, West Virginia and much of central Appalachia was decimated by the industrial logging boom via clear cuts to fuel the Industrial Revolution. Railroads were built, and those railroads hauled out all the timber, and sparks from the railroads' operations ignited wildfires across the state, which were largely fueled by slash from the timber boom, things like treetops or unusable timber. These fires destroyed soils and seed banks and reset the region's forested landscape. If you all are familiar with Dolly Sods, it's a popular wilderness area in north central West Virginia. That area has so much exposed bedrock and kind of this moonscape quality to it because of these fires. Those fires literally burn the soil off of the ground to expose bedrock. And of course, you can't talk about land use history in Appalachia without talking about mining. So coal mining also did its fair share to destroy ecosystems in central Appalachia. Particularly in the highlands of West Virginia, coal mines pocked the landscape and still do today. And to create those mines, mining companies had to deforest large stands of virgin red spruce. And then the process of mining and mine reclamation gave us degraded mountain hydrology streams and helped drive our current climate crisis. So these are some both historic and current pictures of West Virginia and what that land use has kind of left us with today. So working clockwise from the top left, we see the dearth of logging roads branching out like spider webs across the landscape. It might be a little bit faint on your screen, but let me pull up a pointer here. If you focus on this road here, you'll see all of these roads coming down. Those are steam cable skidding scars from pulling timber off of a mountain. And that scarring is still prevalent today. They haven't fully healed over, and we still see the hydrologic impacts from that too. The larger picture on the right shows a reclaimed coal mine, and I use the word reclaimed here in my notes in quotation marks because reclamation is not ecological reclamation. It's making sure that the mountain won't fall down when it rains. So those soils are incredibly compacted. You can see right here, this bench, there's almost nothing growing on it, at least no tree species or no woody species. It's a lot of grass. Historically, this would have all been forest. That's comes in part from the heavily compacted soils during the reclamation process. And that's a photo that was taken relatively recently, within the past decade. And then lastly, the photo on the bottom left shows a logging train pulling old growth timber off the highlands and leaving large tracts of deforestation in the wake of the industrial logging boom. So if you think that narrow gauge trains like this, tracks were laid all up and down the hills and hollers of central Appalachia to pull timber out more efficiently, and the sparks from these railroads would have thrown sparks into all this slash and dead trees. And then that's what lit fires that burned in some cases for decades, which helped destroy the seed bank and destroy soils in the area. So we've talked about kind of the big ideas of what those impacts were, but how did it touch down in the spruce ecosystems? There are estimates that spruce coverage in West Virginia ranged anywhere from 500,000 to 1 million acres pre-Columbian contact. And today, spruce forest exists on a mere 1/10 of the low-end estimation of that former coverage, about 50,000 square acres. Excuse me, 50,000 acres. As we saw in the previous spruce range map, spruce forests are now highly fragmented, which really poses a threat to genetic diversity, habitat connectivity, and has created a wealth of downstream ecological impacts, which include things like our streams in West Virginia are often heavily degraded or incised, as water doesn't have the time to seep into soils and ultimately into the groundwater table, but instead rushes down mountains that have been deforested, and slowly sediments get deposited then further downstream than they would have naturally. And maybe one of the biggest take-home points of all of this is that this industrial land use across all of Central Appalachia reset the successional development of the area. We went from old growth stands to, in some cases, bare soil, or in even worse cases, bare bedrock, where that soil was burned or washed off mountains. So we went from millennia of evolution and building up of forests, and basically pressed the reset button on all of that and sent it back to zero. And as we talked about with our spruce ecology to begin with, they're a slow growing species. They're a late successional species. They thrive in this old growth condition with small canopy gaps, and are not competitive in the short term with other hardwoods like maple or birch or beech. So one of the better documented impacts of these massive land use changes is the frequent flooding of Pittsburgh in the early 1900s. That picture on the left is taken in downtown Pittsburgh from a flood, I believe, in 1907. And so the West Virginia highlands are the headwaters of the rivers that envelop Pittsburgh. Without the forest there, and now with heavily degraded streams, flooding became a very common occurrence. This in part led to the establishment of the Monongahela National Forest in 1920. And now the Forest Service owns almost 1 million acres in east central West Virginia, which represents much of the historic extent of red spruce within the state. Most of my work takes place in the Monongahela National Forest because their property boundary encompasses some of the best remaining spruce forests that we have. So conditions today. Spruce are largely isolated on high ridgetops, like we see here. This is kind of the Dolly Sides landscape that I had mentioned earlier, where you have all this exposed rock. They're also in subpar fragmented stands like here. This is from Canaan Valley in West Virginia, where you have little pockets of spruce, but it's by no means a forest. And then they're often suppressed in the understory. This is probably the most common condition we see right here today, is a forest amidst a middle-aged forest of hardwoods with a slowly growing spruce understory. We can think if we left this forest alone for, say, another 200, 300, 400 years, that eventually these hardwoods would age out of the system, and we'd start to build up those old growth or late successional characteristics, like those small canopy gaps. And those spruce would eventually work their way up into the canopy. But it's a very slow process. We're still recovering from pressing that reset button on the successional pathway from the industrial logging boom. This map on the right is a popular one in my work. If your monitor resolution is set in such a way, you may be able to see the gray outline here. That light gray outline is the former range of spruce in West Virginia, pre-industrial logging, and then the shades of yellow and green are what represents current extent of spruce. Yellow being areas that have less than 10% spruce in the canopy, up to that dark green, which represents upwards of 50% spruce in the canopy. So why here? Why Central Appalachia? Why West Virginia? And why now? You'll learn if you've ever met anybody from TNC or had another TNC person give a presentation that maps are very much our love language. So I'm gonna pepper you all with 3 or 4 US scale maps here. So this map shows biodiversity hotspots within the lower 48 and Hawaii. And you can see that Central Appalachia holds some of the highest biodiversity levels in the country, and especially the highest in the East. This makes the conservation and restoration work being done by TNC and partners that much more important. Preserving biodiversity is our way of preserving the building blocks of evolution into the future. But we know that biodiversity isn't static. So this map is a model showing the gradual movements of mammals, birds, and amphibians across the landscape in response to climate change. We know that these species are moving roughly 11 miles north and 36 feet upslope per decade. So we're not just in a critical biodiversity hotspot, but we're also in a critical section of this biodiversity highway. So you can see right through here, I might not have my pointer on. There we are. Right through here in central Appalachia, we have this high concentration of species flow coming from the south, the east, and the west. In part because Appalachia is bounded on both sides by agriculture and development. The Monongahela National Forest, the GW Jeff National Forest, Shenandoah National Park, all of those areas represent pretty large swaths of undeveloped land. And then you consider what Ohio looks like, or what central Kentucky looks like, or central Virginia, or central Carolina. Those are pretty developed areas. So we've essentially created a funnel that moves species from the south, east, and west up through central Appalachia, and then they're able to disperse into the New England regions, as this model would suggest, over time, slowly, with that 11 miles north and 36 feet upslope per decade. And then the last of the three maps. In our landscape, the mountains, valleys, nooks, and crannies, and numerous microclimates and diverse ecosystems are in close proximity to the heart of the network of highest priority, most resilient, and most connected lands in Appalachia. I could spend an hour going into the nitty-gritty of how this map was developed and what exactly it shows. But the main purpose of including it is to show that here in Appalachia, we have the best areas of future climate resilient, biodiverse, and areas open to species flow within the East. So protection and restoration of these forests within Virginia, West Virginia, Pennsylvania, Maryland, North Carolina represent a massive boon to potential species movement as we experience the realities of climate change. So I've shown you all these maps with the critical connection corridors and the climate connectivity, but what critters call spruce influenced forest home? So this is just a very small subset of species endemic to spruce forests or dependent upon spruce forests for some part of their life. But working clockwise from the top left, we've got the spruce knob three-tooth snail, the Monongahela crayfish, and yes, they really are that blue. Long-stalked holly, which is a G3S2 species, meaning it's getting closer to globally rare and certainly state rare, and is considered imperiled. The black Burnian warbler, the saw-whet owl, the Virginia northern flying squirrel, which has become one of the chief indicator species for how we measure success of our spruce restoration work. The brook trout, which has become the key indicator species for aquatic restoration work in West Virginia and throughout central Appalachia. Some of the most southern populations of snowshoe hare are using spruce forest. Monk's hood, it's a G3S3, considered vulnerable species. And lastly, the Cheat Mountain salamander, which is endemic to a very small range of what is Cheat Mountain in West Virginia, and is dependent upon spruce forests. So many of these species, like I mentioned, are either globally rare, rare within central Appalachia, or both. So why spruce restoration and why central Appalachia? And maybe most pressing, why now? Simply put, surviving climate change, preserving biodiversity, and ensuring ecosystem resilience answer those questions. Spruce influenced forests are the coolest and wettest forests we have in the region. And as climate change gets hotter and drier, these forests will provide critical refugia for flora, fauna, and fungi. Now's a good time for a break. Does anybody have questions on basic spruce ecology, land use history, or the why here, why now components of this work? All right. Waiting for the critical awkward silence. We'll keep moving. So now I'm going to get into the restoration methods. We've kind of talked about how we got here, why it's important that we're doing this work, and why we're doing it now. So what are we doing to restore spruce forests? This is not going to be an all-inclusive list, but I will focus on three topics of interest to me personally assisted migration, tree release, and riparian restoration. So in TNC's Central Appalachians program, they have a team of conservation staff focusing on advancing climate resilient forest management. That team contributes to the science and guidance on climate adaptation and to demonstrate and leverage new forest climate adaptation methods in vulnerable forest ecosystems like red spruce ecosystems. I've got a video here that was put together by some of my colleagues, kind of giving you all a brief overview of what that climate adaptation work is, and then I'll get into the nitty-gritty of it a little bit more after the video. If it doesn't play for you, let me know.
Is there audio?
There is. Are you all not hearing that?
We are not.
Okay. In that case, I'll send you all the video afterwards and we'll
Okay,
skip it for
good.
now.
Thank you.
Yeah. All right, let's bump forward. Okay. So the idea behind assisted migration is that, as I noted earlier, we have these kind of pockets of spruce throughout the landscape, but they're not connected. Spruce can only pollinate each other within about 400 feet. So if you have canopy trees that are separated by more than 400 feet, or in some cases separated by miles, they won't pollinate each other, won't create viable cones, we won't have any spruce regerminate, and then they'll fall out of the system and we won't have any spruce there again. So the idea behind assisted migration is to improve that genetic diversity within a stand so that we can maximize the adaptations that spruce have built up over time as we expect as we expect climate change to become more and more harsh for spruce. So one idea, to put it very simply, is if we take trees from the furthest southern range of spruce and start planting them a little bit further north, as we expect to see the natural range of spruce shrink and the southern edge creep further and further north, by planting those spruce here, assisting them in natural migration, we would hope that those trees would be a little bit more resilient to future climate. So this map shows genetic diversity of spruce throughout the current range. And you'll see, as expected, the areas of smallest spruce pockets, mainly West Virginia, southern parts of Virginia, and into the Carolinas, are those that have the lowest genetic diversity, meaning they're most yellow on this scale. And notably, spruce in the highlands of West Virginia in particular have the lowest genetic diversity of any spruce within the entire range. Oop, excuse me. So we know that our high elevation red spruce forests in central Appalachia will be vulnerable to future climate change. So to find practical climate adaptation solutions, we knew we needed to work with a team across science, the practices of science, conservation, and implementation. So we know from the science folks that we work with that have been working in spruce genetics across the apps that the spruce forests in central Appalachia have very low genetic diversity. And we know that genetic diversity is the raw materials that allows a species to evolve with a changing environment. If there's greater diversity, there's more likely to be individuals and populations that will survive and reproduce and ultimately thrive given a new climate reality. So to enhance spruce forest's ability to adapt to climate change, we source spruce seed for restoration projects using the natural genetic variation in spruce populations across central Appalachia. So in the fall of 2019, one of the partners that we work with collected red spruce cones from about 6 locations in central Appalachia, which included locations in Maryland, West Virginia, and Virginia, and processed these seeds and then shipped the seeds out for production in a greenhouse in Oregon in the winter of 2020. The 6 sourcing locations were determined by an analysis done by the University of Vermont of potential spruce populations in Central Appalachia to identify which populations would improve the genetic diversity and minimize the genetic load of our restoration sites. Genetic diversity is just what it sounds like. It's how diverse the genetic pool is you're pulling from. Genetic load is not as clear, but think of genetic load as the maladaptive traits. So if genetic diversity is the positive traits we're trying to look for, genetic load are the negative ones. So we're trying to maximize overall diversity while minimizing the known negative traits that have evolved within certain spruce. Those sites were 2 TNC preserves in Western Maryland, the Monongahela National Forest in West Virginia, where I do most of my work, and then Beartown Mountain down in Virginia, which spans a TNC management easement, and the Clinch Wildlife Management Area in Southwest Virginia. So advancing current practices in the spruce restoration community to take this climate adaptation approach has been successful largely because we've worked together across silos of science, practice, and conservation. I found that oftentimes these groups, the implementers, the conservation planners, and the scientists don't always talk to each other in a meaningful way that advances positive, thoughtful restoration. So by intentionally choosing this project and choosing the best scientists and folks who were working on this area on the ground, and then some planners throughout TNC, we were able to get those silos to talk to each other. And because of that, we were able to put kind of a fairly forward-thinking assisted migration approach into practice. It's often something that's just talked about in theory, but to put it in practice as a pilot to potentially scale up in the future is a real win for that collaborative cross-silo approach. So the goal ultimately for this project was to pick populations in Central Appalachia. Oh, excuse me, I jumped ahead. So to figure out which seeds to select, what areas to pull seed from, the folks at University of Vermont created a short computer program that looked for optimal combinations of 3 to 4 potential seed source populations within the region near the restoration site that resulted in the highest ratio of genetic diversity to genetic load. Again, that's maximizing diversity while minimizing load, all in areas relatively close to where we were planting. Those seeds with maximum diversity and lowest load represent our best current advice on seed to minimize the effect of inbreeding depression, and maximize diversity and the potential for evolutionary responses to future climate change. And ultimately, this helps maintain local adaptations within the Central Appalachian ecoregion. If we're sourcing seed with high genetic diversity, say from just a couple ridges over, and can bring that to an area that has really isolated stands of spruce that aren't self-pollinating, then we can start to boost the genetic diversity without introducing a whole suite of potential issues from bringing spruce from, say, 400 or 500 miles away. These are not massive movements. They're fairly small, but since spruce are slow to move and they require that wind-blown pollination of only up to about 400 feet, even moving spruce from one ridge to another or one side of the mountain to another can really improve genetic diversity. So the second of the 3 restoration practices we've used is tree release. So we talked a little bit earlier that the issue is spruce can persist in these shady understory conditions. They're really tolerant and really resilient, but they're not very competitive. And since we have a pretty young to middle-aged forest in much of Central Appalachia, because we pressed that reset button on successional pathways during the industrial timber boom, we have forests that are, roughly 80 to 120 years old, but spruce do best in forests that are closer to 300, 400, 500 years old. So the release events that get those spruce up into the canopy are pretty rare in these mid-successional forests. So like I said, spruce is shade tolerant, but not shade loving. They get established in these really low light conditions and can persist for a long time in the understory, but have to have those release events. And since those release events aren't common, and we don't expect for them to be common until these forests age, we have a bit of a problem that these forests are in a state where they're not getting the natural disturbance that spruce require, and they won't get to that state until long after the realities of climate change are firmly realized. And at that rate, we're not sure if spruce will survive in those warmer, drier climates. So we go in to help mimic that natural disturbance, but doing it at a scale faster than what Mother Nature would do given the current age of these forests. Much of this work is derived from a paper published in 2016 from doctors Jim Wrench, Mark Ford, Jamie Schuler, and a handful of others. And the big takeaway from that paper is this quote that I'll read to you. That a tree-centered release approach utilizing small canopy gaps that emulate the historical gap phase disturbance regime provides a good strategy for red spruce restoration in hardwood forests where overstory spruce are virtually absent and where red spruce is largely relegated to the understory, which is essentially the vast majority of the current red spruce range within West Virginia. So this has become our restoration approach. We go into these stands, create a canopy disturbance that would mimic what would happen naturally in an old growth forest, but at a faster pace to reestablish healthy spruce influence forests throughout Central Appalachia. So what does this look like in practice? What does tree release look like? On the left, you see what probably looks like a pretty typical northern hardwood forest in summer. It's very green, it's very lush, it's very dense. There's not a lot of light reaching the ground, and the trees are pretty small. They're not those big, chunky, old growth virgin trees that we saw in the historic land use slides. They're middle-aged trees for the most part. So we go in, typically with herbicide. We've tried in the past with chainsaws and found it to be somewhat ineffective, so we've switched to an herbicide approach and cull hardwood trees. Specifically hardwood trees that are in vast abundance in the area. So we take things like red maple, sugar maple, yellow birch, black birch, and American beech where it's diseased. We have beech bark disease pretty prevalently here in West Virginia. So where we find diseased trees, we take them knowing that they're not going to be in the stand for too much longer, and we don't want them to reproduce more disease susceptible trees. So although these two pictures don't show the same stands, they do illustrate the size gaps we're making and the site conditions we're aiming for in the end. These spruce here and here got established in a thick understory, but we fear that they would age out of the system and if they don't get that release. So we go in and cull these canopy trees to get them that release. So they'll start to inch their way closer to the canopy where they can start to influence the ecosystem, start to shade out competition, start to build up soils, start to sequester carbon, and start to restore natural hydrologic processes that I'm going to touch on here in a minute, excuse me. So the goals of tree release. Our long-term goal is to release enough spruce to put the ecosystem on track to have at least 30% of the canopy covered by spruce within each release unit. That level of spruce, the level of spruce release that we want is determined by management goals. So how we got to 30% is largely dependent upon the northern flying squirrel that I showed a little bit earlier. A paper by Dr. Mark Ford out of Virginia Tech, who's kind of the leading squirrel expert in the region, showed that once these systems get to about 30% spruce in the canopy is really when the squirrel population starts to take off. And these squirrels are spruce dependent. They eat a mycorrhizal fungi that grows on the roots of spruce during summer, and then they eat lichen in the winter. So we know where if squirrels are present and with a robust population, we know there must be enough spruce in the area to provide the food source. So that 30% is what we've deemed our minimum management threshold to achieve our restoration goals. Now, this release work is done with an eye towards maintaining canopy diversity of the trees in the stand already. So we're not taking trees that have what we've determined to be high ecological and wildlife value. Couple of examples would be serviceberry. We never take a serviceberry because it produces good soft mass for wildlife. We rarely take black cherry because of the same reasons, good soft mass for wildlife. If we're in an area that has like some unusual or rare trees for our area, we don't see like a lot of basswood. We typically don't see much of. We don't see a lot of American hop hornbeam. If we get into a stand with those trees, we leave them. If there's spruce below them, we leave them suppressed. We're generally aiming to release spruce that are suppressed by the most abundant hardwood trees in our area, which are, like I said, maple, beech, and some of the birches. And we do that release in 2 phases. The first is a detailed site and landscape assessment, where we go, we do a mix of on-the-ground scouting and desktop scouting. So I'll get on Google Earth and poke around and see leaf-off imagery in the winter when there's snow on the ground. It's really easy to spot spruce. They're the only green thing on the landscape. So I'll look for these clumps of dark green and say, okay, we've got a 100-acre unit here with a clump of green here and a clump of green on the other side. I want to release spruce to create a corridor between those 2 well-established canopy stands of spruce. So our goal is to release trees that have the best health and vigor. If we see a tree that looks pretty scrawny, is a little raggedy, maybe was damaged either through buck rub or from another tree falling on it, we're not going to release that tree. We're looking to get the best trees we can into the overstory as fast as we can. And we do all of this work as part of a large partnership. Like I said, I work a lot with the Monongahela National Forest, but together with several other partners, we've created CASRI, which is the Central Appalachian Spruce Restoration Initiative, where land management partners, federal, state agencies, and nonprofits come together to pursue spruce-focused management, whether that's planting, protection, release, or trying to better connect the science community with the restoration community. And ventures like CASRI have been largely successful in having all of these different agencies and organizations collaborate with each other to share the best science and best practices so that we're constantly learning and getting better rather than reinventing the wheel every time a new agency or organization gets on board with spruce restoration. So since we began this work in 2014, we've completed over 4,000 acres of spruce release. We've combined that with some monitoring work to see if what we're doing is effective, and if not, to change course. So that monitoring work shows that a fully released spruce, which is represented here by canopies, so this spruce had the canopy removed above it, along with the mid and understory. Spruce that are released and receive a full canopy gap grow at over double the rate of spruce that aren't released, shown here by unreleased. So if these canopy gaps that we create remain open for, let's say, hypothetically 3 decades, the spruce within the canopy gap would grow 7.5 meters compared to the unreleased spruce, which would grow 2.4 meters in the same 30-year period. That difference could mean the difference between getting spruce to the canopy, where they can ultimately influence the surrounding forest in a climate change relevant time frame, or letting those same trees die slowly in the understory while they wait for a release event that's unlikely to happen in a middle-aged forest. I'll also note that the Forest Service has been a great partner with advancing spruce restoration. There's currently an environmental assessment being drafted by 5 forests in Central Appalachia. So they include the Monongahela, the George Washington Jefferson, the Cherokee, Pisgah, and Nantahala, all down in North Carolina, that focuses on spruce restoration. So this EA, this environmental assessment, crosses internal Forest Service regional boundaries and 3 states, all at the southern extent of the spruce range, with the ultimate goal of accelerating spruce restoration across these forests, so that rather than having to go and do individual EAs every time that a forest wants to do spruce restoration, they can instead create this bigger, more overarching spruce restoration plan that will encompass 5 forests so that the Forest Service in the southern extent of the spruce range is all those forests are collaboratively working together to advance the same goals rather than doing so independently. So the last of the spruce restoration work I wanted to talk about is riparian restoration work. As I noted at the beginning of the presentation, the spruce ecosystem represents the headwaters of many rivers and streams that flow through towns and neighborhoods throughout central Appalachia and even into some more major cities. For example, the headwaters of the Potomac start in northern West Virginia, and the headwaters of the Monongahela that flows down to Pittsburgh start in the Monongahela National Forest. And flooding represents one of the largest climate-related threats to people in this part of the world. Spruce-focused riparian restoration helps to rebuild soils that hold water and will build up the sponge. So as it rains, these thicker soils will start to hold more water and more slowly release that water out into the stream rather than thinner or more compacted soils. It's more akin to rain falling on concrete where it's immediately running off and the soil doesn't have any time to drink that water up and soak it in. So the spruce-focused riparian restoration helps rebuild those soils, which will ultimately help mitigate flooding. Shaded streams are also really important in the highlands of West Virginia, mainly for cold water fish species like brook trout. That's kind of an anomaly to have here, to have brook trout at such low elevation and so far south. But much of that is attributed to the history of red spruce in this area, shading out those streams, building up those soils so that that water, rather than staying on the surface of the ground, can go underground where it's a consistent cooler temperature. The streams shaded by spruce help maintain those brook trout populations, help maintain habitat for other cold water fish and aquatic organisms. These riparian areas also represent corridors of critical habitat. If we think of streams as bridges between pockets of well-established spruce, if we have a pocket on one side of the mountain, say at the top, and another pocket further down the mountain, the one thing that connects those two pockets could very well be a stream or a drainage. And so if we plant those areas with spruce, and if we release spruce in those drainages, we can help to not only build up soils and keep water cold, but create bridges between these isolated pockets of spruce. Now, this is probably one of my favorite photos in the whole presentation. The photo on the left shows leaf-off aerial imagery of a degraded stream. This is in the Monongahela National Forest. I believe it's an area that we planted 2 years ago, full of spruce. It's a high elevation valley, essentially. These are ridges, ridges, and ridges. And then this water pools up here in this deforested area. Those pockets in dark green that you see here and here and here, those are spruce. And so you can see how replanting spruce along this corridor will connect disparate patches of established spruce forest. We can connect this spruce forest here to this one, and then further downstream to this one by replanting this area. Also from replanting, we can have water shaded out by mature spruce coverage eventually. You'll see in this picture right here, this shows the benefits of downed woody debris in streams to create aquatic habitat. In an older forest, as trees naturally are falling into the stream, you get a lot more woody input into the stream. That creates pools and riffles like you would see in a good brook trout stream, and helps water during flood stage reconnect to the floodplain because you've raised up the elevation of the stream just a little bit. So now instead of further incising the stream bank as water flows downhill, instead that water spills out of the stream, goes into the floodplain and seeps back in rather than just piping itself down the stream repeatedly, which would result in more sedimentation for downstream species. So that downed woody debris here is beginning to enter the aquatic system, which will ultimately create complexity and structure for species like trout. So not only are we planting in riparian areas, but we're also trying to get these trees more established so that as we get those older forests, as we cull the hardwood trees near streams, eventually they'll fall in and they'll create that more complex aquatic habitat that we're looking for in a healthy, high elevation stream. And then lastly, kind of some final thoughts on all of spruce restoration. So I'll just read this quote. Restoring red spruce isn't single species restoration, it's whole ecosystem restoration. Spruce does so much to influence the ecosystem that it sits within, that by focusing on spruce, we'll have a lot of downstream, pardon the pun, impacts that are positive, like building up soils, like creating colder, wetter microclimates for climate refuge into the future. This work is critically important to protect the biodiversity and climate resiliency of the Central Appalachian Highlands. So that's about what I had. I hope y'all maybe learned something, maybe got something out of it. Do you all have any questions?
How do you determine the biodiversity of a seed?
Oh, the genetic diversity of the seed?
Yeah,
Yeah, so folks up at University of Vermont have been doing this genetic analysis. So this is getting a little bit out of my wheelhouse for how they actually determine it. But from how I understand it, they analyze these seeds for their for the DNA and then run that through a computer system that they've input other spruce seeds into and are able to pick out the differences when it's run through that program, kind of pop out and then show you what's the components of diversity within those different seeds that they collect.
I was curious about the spruce because there are other evergreens around here that have diseases like is it the woolly adulate? Are there
Yeah.
any problems with the spruce with that other than the because you do get the spruce budworm that you see. I used to live in Vermont, so you'd hear about problems with that.
Yeah,
What
as
about-
of now, there's no spruce budworm that I'm aware of in this part of the world, in Central Appalachia. We do certainly see a lot of hemlocks dying out, especially in warmer environments. At least where I'm at in West Virginia, the hemlocks seem pretty healthy. But as you go up like into Pennsylvania, where it's a little bit lower in elevation, you'll see a lot of hemlock die off. One of the thoughts around spruce restoration, one of the restoration strategies, which I didn't talk about today, is to underplant hemlock stands with red spruce, so that as the hemlock die out through the woolly adelgid, that the spruce will be there to take their place, so we don't lose that coniferous cover, which gives us those thicker, more acidic soils that shade out streams, and creates that cooler, wetter micro habitat. So that there's some work being done in the highlands of West Virginia, particularly at Canaan Valley National Wildlife Refuge, where they've gone in areas with a strong hemlock component and underplanted spruce. The idea being that when that hemlock dies, it'll create a release event for those spruce saplings, and then they'll start to work their way up through the system.
Do you think that the gardener, the urban gardener, has a role somewhere in this? Or is it
Hey.
really truly just in the forest?
That's a good question. I think it depends where you live, quite frankly. I mean, if you were interested in growing spruce on your property, they're really tolerant of a wide variety of conditions. It's hard to find a place where they won't grow. So could you grow spruce on your own property? Yes. If you live in an area with spruce, and say your property doesn't have spruce, I think planting is a great opportunity. We encourage folks to plant spruce in Canaan Valley, where there's a lot of spruce there already, but they may not have any on their own property. In terms of growing spruce kind of outside of where it's already established, I don't know that there's much viability in doing that for a restoration component, unless it's specifically to like shade a stream. But if you're kind of in that larger matrix of where spruce are currently, I think more spruce on the landscape is largely a good thing. You could run into problems about pollination if you're not near another viable canopy spruce. If it can't pollinate, then you can't get viable cone. So I think there's a potential role for it. As far as like the backyard gardener just in Anywhereville, USA, I don't know that it's I think there could be more important things to grow, like pollinator habitat.
Okay, well, I was thinking, in the part of Blacksburg where I live, we have a lot of Norway spruce.
Yeah.
And, I know some years we have a lot of, say, red-breasted grosbeak, nuthatches, and some
Mhm.
birds that are, they kind of migrate down here depending on what the red spruce, I'm assuming they're red spruce up north, how
Mhm.
good they are with cones. And I mean, we have a lot of people who've planted hemlocks
Yeah.
and they're growing fine. They're, a lot of them are hedges and sheared, but not all of them. I'm just thinking, if you think about a whole neighborhood maybe we're not high enough in Blacksburg that it would be of any value at all.
I think if you've already got a lot of Norways, it could be of some value. Um, we have a lot of Norway in the Monongahela National Forest. It was largely planted by the CCC as just a tree they could get their hands on during the Depression. But they fulfill a lot of the same ecosystem niche that red spruce does in terms of acidifying soils and building up soils. And um, they're they're not as good for the flying squirrel. Because as far as I know, that fungi doesn't grow on their roots. But if you already have bird species using Norway and hemlock in part of their migratory path, then I think certainly red spruce would it certainly couldn't hurt, and I think it'd be beneficial.
It might be interesting.
Yeah, absolutely.
I don't know. I really found it interesting about the flood restoration, about wood falling into the creek and raising the water level. And I hadn't really thought about that before. Thank you.
Yeah,
It was very interesting.
thank you. Other questions? I heard somebody start talking, but it was a little broken on my end.
That was my husband. Sorry.
Oh, okay. All right. Well, thank you all for inviting me. I certainly appreciate it. This is the vast majority of my work is in red spruce restoration, given how unique and special it is to Central Appalachia. Forests like the one you see in the background here, are like a little slice of New England or Canada, that we're really lucky to have here. And I think without protection and restoration and degraded lands, that we're at risk of losing it. So I'm happy to have an audience to keep preaching the spruce gospel to. And then I'll follow up with you all with a link to the video that I had in there that the audio wouldn't come through. So that'll provide a little bit more context for that assisted migration program that we've been working on with folks out of University of Vermont.
Barb, you're muted. Thank you very much. Well,
Sorry.
that was really,
I just said thank you too. Thank you. Now I'm going. Bye, everybody.
thank you, Will. That was really interesting. I really enjoyed that. I'm from Vermont, and so I'm used to seeing a lot of red spruce, and I've been up through Canada and areas where a lot of the finches would be seen in the trees. I mean, they're all up there to breed, and things like crossbills just
Yeah, yeah.
flood the spruce forests up there. It's a pretty spectacular thing to see.
Maybe one thing I'll leave you all with, kind of going off Barb's question about growing spruce, of maybe ways to help if this is something that strikes you as something you're interested in, planting on your own lands. And then when that Forest Service environmental assessment comes out, hopefully in the fall, if you all are interested in the NEPA process or interested in that large scale planning, I think commenting on that effort is a way to help show our partners in the federal government that people care and that spruce restoration work is important. So if that's something that you all already do or are interested in, I would keep an eye out for that coming through hopefully in September for when that goes live for public comment.
Great, thank you.
Yeah, thank you all.
I just have a few announcements before we end for the evening. we have a picnic date and location that we're still planning. That hasn't been finalized yet for the annual society picnic. Also, this Friday, on the 17th at 6 p.m. is a field trip to the American Chestnut Foundation, Catawba Orchard. Remember, it's going to be a non-trivial hike to get in there to see the site. And also on Saturday, the 18th at 10 a.m., the Kiwanis Park field trip is going to be led by Beth Umberger. So that should be an interesting trip as well. I just want to make sure that people don't miss these trips that are coming up soon. Does anybody have any other announcements they would like to make? Nothing? All right. Anybody from the room here? We're all set then. Thank you so much, Will. And this meeting was recorded and will become available to people who weren't able to make it this evening. So thank you very much.
Thank you all. Have a good night.
Good night.
I couldn't hear a lot of it, but it seems like he gave a really good presentation.